Welcome to this Wood Solutions campus presentation on the grades and grading methods for sawn timber and similar products used in structural applications. Sawn structural timber and similar engineered wood products are the most common and widely available wood products in the Australian market. About 5 million cubic metres of sawn structural timber is produced in Australia each year, and it is regularly used in the load-bearing elements of buildings, bridges and similar structures. The National Construction Code, or NCC, sets the minimum fit-for-purpose requirements for structural timber as it regulates all structural applications in buildings. So every timber element used in a building structure has to satisfy the requirements of the applicable engineering design standards. Timber elements can do this in two ways. They can comply with the requirement of the relevant structural grading standards, or alternatively, companies can provide independent engineering certification for the product's structural performance. This presentation concentrates on the first of these methods, complying with the relevant structural grading standard. The second method, independent engineering certification, is often used for LVL, I-beams and similar engineered wood products, as the structure of established stress grade may not give a useful representation of their performance. When the timber is assigned a stress grade, it is held to have those structural properties. Major stress grade systems include F grades, MGP grades, and GL grades. With each of these, the higher the number assigned to the timber in the grade, the higher the strength. So MGP 15 timber has a higher assigned strength than MGP 10. This table is from Australian Standard AS 1720 and it lists the design structural properties of F-graded timber. As the grades progress from F4 through to F34, the structural properties increase. Different strengths are used for bending, tension, shear and compression. The ratio between each of these was chosen to be a reasonable fit for most commercial hardwood timber species in Australia. Other stress grading systems use ratios aligned to be a reasonable fit for the performance of other products. For example, the ratios used in the MGP system best fits the performance of major pine species. There are some key points to remember about grades and grading schemes. First, the grade term describes the minimum performance assigned to the piece. The piece may qualify for a higher grade if it was regraded. Grade terms are species and product independent. A piece of F17 softwood LVL has the same assigned performance as a piece of F17 sawn hardwood. If they are the same size, they are interchangeable in a design. Lastly, grade schemes are not interchangeable. The grade and performance definitions for F and MGP systems are not the same. Some MGP grades provide performance above the requirements of some F grades. However, F grades do not align well with the requirements of MGP grades. F grades apply to both seasoned and unseasoned hardwood and softwood. The material is visually graded. Common stress grade terms include F5, F17, F27 and F34. The key standards covering F-grade material are AS 2878, timber classification into strength groups, AS 2858, timber, softwood, visually graded for structural purposes, and AS 2082, hardwood, visually stress graded for structural purposes. MGP grades apply mainly to seasoned softwood, as the letters MGP are shorthand for machine graded pine. MGP is the predominant grading system used for pine framing and is only used for seasoned material. Unseasoned or treated pine product, however, use the F-grade system. Common MGP grade terms include MGP 10, MGP 12 and MGP 15. The key standards covering MGP grade material is Australian New Zealand Standard 1748, timber mechanically stress graded for structural purposes. GL grades apply to glue laminated timber sections, as the letters GL are shorthand for glue laminated. Common grade terms include GL8, GL12 and GL18. The key standards covering GL graded material are AS 1328, glue laminated structural timber, AS 1491, finger jointed structural timber. The process of grading is based on a correlation between the piece's structural properties and grading parameters. These parameters have been developed after years of experience and testing of a very large set of material samples. During grading, the parameter is assessed and a stress grade assigned based on the result. Trained graders visually grade timber to the F-grade system. The species of timber is determined and standards assign this to a strength group. The grader then assesses the natural characteristics in the piece, looking for strength reducing features such as knots and sloping grain. Taking these into consideration, the grader assigns a strength grade to the board. The strength group of the species and strength grade of the boards are then combined to provide a stress grade for the piece.
When you're grading a board, you've probably, depends where you are in the line, but you've still only got probably 10-15 seconds to grade a board. So if you're docking it, you're looking at it as it comes to you on the docker, so you're basically grading one face before you get the board. As you grab the board, you grade the edge, you give a look, then you turn the board, you grade the face, and you send it through. So it's something that comes with training and a trained eye and experience. But as we said, that time, that's one person. Then we have the person who does the actual formal grading on the line. He grades it as well. And then the guys putting it into the packs of timber, all graded as well. So any one person out of those 5 guys has the authority to put that board out.
To vary the grade if they feel it's appropriate. That's
right.
Okay.
Our graders are all trained through Creswick, the timber training, and we've just put another batch through only a month or so ago. So we make sure that everyone on that line can visually stress grade to the Australian standard, and they're certified to do so.
In mechanical stress grading, the species of the timber is known. This is the first parameter. The timber then goes through a dynamic bending machine at high speed and subject to a non-destructive bending load on the flat along most of its length. Its stiffness, or how much it bends under this load, is determined, and this stiffness is used as a surrogate from the full structural properties of the piece. This is the second parameter. The minimum stiffness measured in the piece determines the grade of the whole piece. This can be an F grade or MGP grade. Usually, the grade is sprayed or printed on the board. After the timber is machine graded, it may be visually checked to ensure that the machine grading is robust. In summary, structural timber elements must satisfy the requirements of the engineering design standards by complying with the structural grading standards or by independent engineering certification. When graded, the timber receives a stress grade. This describes the piece's minimum performance. Major stress grade systems include F grades, MGP grades, and GL grades. Grade terms are species independent and grade schemes are not interchangeable. And structural grading is based on a correlation between the timber's structural properties and grading parameters.